Sure. Okay, so we want to demonstrate for you guys today the Veyron V2, which is the chiplet that we're trying to get taped out within the next year. And so this actually supports RVA23, which a lot of people have been hoping to find a board that will support that for a while now. This will be one of them, which necessarily means the H extension will be supported, vector will be supported, and we wanted to demonstrate that we actually have that working on an FPGA, which looks like that. That FPGA is not far from here. It's about 20 kilometers away, but it's unfortunately stuck in customs, so we couldn't bring it. We had planned on actually having it at our booth the entire time, from even yesterday. And so we can't do a demonstration on it because it's not plugged in, and we can't show it to you either. But we do have a QEMU model, which is an exact replica of that, which we use, of course, for developing our software. And so we will still show you the software stacks that we had intended to demonstrate on that, and you'll have to take our word for it, but we can assure you they also work there. I think we're ready to go right to the demos.
Great. So let's go here. On the left side, you see like a running Ubuntu 23.10, I think, which is now running inside our FPGA model. And what we can first do is like I've already logged in as the user of Ubuntu, and what we first wanted to show you is like the program NeoFetch, which is a systems information tool, just works. I mean, I installed it like 2 hours back with apt-get install just out of the box, and it works. It shows we're running 23.10 RISC-V 64 on our Thunderhill FPGA model with a pretty recent kernel. So that's basically what we have. So the next thing is Ubuntu also runs Apache and all the regular data center applications that you know. So as a proof that it works, I have an Apache running here. So check the URL. It's localhost, so it's tunneled inside the KVM or QEMU virtual machine, and we can just load our landing page here. So, and this is all running live inside the model. Then I'm going to go to the data center software stack. There's lots of applications that we could show you right now, but due to time constraints, we're going to focus on a simple thing. So again, web server will just go to Apache, and that shows another landing page. It's pretty outdated right now, but things just work. Another thing that works is, for example, PHP myadmin. Oh, I'm logged out now after inactivity, but like all the regular data center applications that you know just work out of the box. And as an example for that, well, we have those here, and as you can see, things look pretty good. There's also WordPress and stuff, but we're not going to go into detail. Another thing that works is like compiling stuff on the fly, of course, and in the interest of showcasing AI and vector instructions, I have an X264 minimal example here. That's a hot loop from the X264 Spec 2017 benchmark that does basically, well, sum of absolute differences here. And, well, that's just the code. The details don't matter too much, but what we can do is use, no, that's not here, opt, where is it, GCC. So we're just going to use our own downstream GCC, optimize, and use our own Ventana Veyron V2 model to compile the code I just showed you. No, sorry. So this basically also just works, and we got running, hopefully soon, working a.out, which produces an example. To also show that like ancillary tooling works, we have a running perf here, which we can showcase. Just a second. Perf 2. Oh, it's gone again. Oh well. Opt perf bin perf2. I'm going to do a perf record of a out precompiled non-vectorized version. So it records, and we can show the results right here. So, oh, it's in white. Well, never mind. Can zoom in and see that like RISC-V instructions are produced and running, and like the proper result is also here. Then I'm going to record a vector version of the same thing I just did, optimized for Veyron v2. This is going to take a bit longer due to QEMU, but we can show then that like once this finishes right now, going to go into detail, the perf report, and see that this time we have a lot of vector instructions there with a V prefix, VZ, VLI, VAdd, and so on. And in particular, some strided loads here, which is pretty specific to RISC-V. So this also just works and is optimized for the Veyron v2 model, just using out-of-box upstream tools. I don't know how we are with time.
We still got a few minutes left.
Okay, so another thing I wanted to show is we have a custom matrix multiplication instruction that also works, and I've pre-compiled like a matrix multiplication example. I think that's var1. Oops, it's gone again. So that I'm going to run again. So this one is basically like linear algebra library called Bliss, which I extracted a small example of, showcasing that it can run our own custom vector matrix multiplication instruction. What's not supported yet is perf cannot handle this instruction. It will just show an INSEN, but it will execute just fine on QEMU, and we'll soon see once it finishes that like basically everything works out. So basically, all yeah, there it is. Let's go into report. So there we have this one here. So you might be able to spot this INSEN thing in perf. That's basically showing that's the matrix multiplication instruction, just not due to lack of perf support. It's not there, but of course it executed correctly and produced the correct result. So I think we still have time for. Okay, then yeah, let's. We still have another like machine learning example, but due to interest of time, let's change to Drew now.
Yeah, thanks.
This one.
So I work primarily on virtualization, and I get a lot of questions when I'm at conferences like this one about when are we going to see hardware with the H extension so we can start running VMs. And as I said, hypervisor extension is actually required by RVA23 profile, so the Veyron v2 will certainly have that. I want to show you once this boots up. I'm actually showing right now just booting a host, so you can see the dmessage logs go by, show that, yeah, we're booting Linux. Nothing, hidden behind the curtain. And then once we're booted up, I'll show you that we can just launch a guest like normal, and we can do that as well on the FPGA when we have one. So a couple more seconds for the boot. So I like to manage my guests with libvirt because it allows you to avoid that really long QEMU command line that you may be familiar with. And so I have one VM I've installed only at this point, but I can just see it there. I can launch it just like you would if you were, say, on an x86 data center or ARM data center host that's running a hypervisor KVM. Nothing is different in that regard. So it's boring as it should be. And this is the guest booting now. So we boot the host first, and now we're booting a guest inside. And this is running with KVM and QEMU, using, of course, the H extension for the virtualization acceleration.
We are out of time.
And we are out of time.
Show the CPU.
CPU info, see, it's real, and we are done.
I know that CPU info is a device to jump, but whatever, we can do device.
No H extension anymore inside the guest.
Yeah, you can see that,
Why it's-
But you have the whole beast.
whereas this is the host CPU info now, which has a few more extensions.
Yeah.
You have the BSET, you have the AIA, you have Vector, up to 64, you have FHB.
512.
Yeah.
512, okay,
Yeah.
but you see the, okay.
Yep.
Okay, PBMT, NAPOT, Inval, okay. You have SB Inval, cool. Okay, whatever. Out of time.
Okay. Thank
All
you.
right, well, thank you very much.
Awesome, thank you. We can have questions afterwards.